look at two among the 4 points that you listed. For the second point, you asked to read about the FRTB standardized approach, CVA calculation. So I read and I have some few clarification. And for the first point, which is the implementation of Monte Carlo's pricing using least square method, I managed to do that.
Oh, that's good. That's good news.
So should I share my screen?
Yes,
So that,
yes.
Okay. Okay. Can you see my screen?
Yes, yes.
All right. I'm facing something now. Okay, so yeah.
What are you doing there?
Okay. So I use a Jupyter notebook to do that. Jupyter notebook.
Okay.
I'm running it directly from the Google Cloud.
Okay.
Yeah. Okay. So when I look at the thesis that you sent me, the first thing that they explain there is okay. First of all, they give the formula to compute the price for an option, American option, and the different here is that the exercise we can exercise it at any point, not that they included the maturity, and that's the formula. Okay, so first, if we want to use the Monte Carlo simulation, we need to first generate some path by solving this stochastic differential equation, which is there, using Euler Maruna scheme. So that's the first. That's the first thing, and I first look at this paper. This paper that the first created this method, least square method. They give an example in the first section. If I open, can you see the paper? Can you see still see what is showing?
No, but I know this paper. It's fine.
Oh, okay, that's all right. Okay, all right. So I try to look at the example that they give there. But first of all, I simulate the path using the Euler scheme by fixing some detail, some parameter that will give me this. But I noticed that the path that I have, that I simulate 8 parts is not exactly what they gave in that paper for the first section, because when I was implementing, I wanted to find the same value. So then I just pick the part that they gave in that paper, because the output that I got here are not exactly the same. Maybe it's because of the parameter that I initially I set. Okay, so should I go through the
Were
note?
the
Or,
value were the
uh,
value close to the one day paper? Were they close or completely different?
they were close, they were close. It's just that I think in that paper they note that the strike price is they set at 1.10 and the time is 1 to 3 years. The riskless rate is 6%, but they didn't give any information about the initial value and also the sigma, the volatility. So I was the
Yes,
one that initially the initial value and the volatility. And when I do the simulation, it give me this. So
okay.
so yes, but it's close to what they gave in that paper. It's close, but it's not exactly the same thing. I think it's because of those two parameter that was not mentioned in the paper. Okay, so yeah, so then I just simulate 6 parts, uh, 8 parts. So sorry, 8 parts, and from there, from the algorithm that is there, first of all, we need to start with the maturity, t equal to 3, and from the maturity we can now go in backward and start evaluating the expectation and check whether the price is less than the exercise uh, uh, payoff. So that's what the first matrix do. So here now, since we have 3 times, 3 equal to 1, 2, 3, then we need to build 3 cash flow matrices. So the first one is what is here. The first cash flow matrices is just the exercise payoff at those different timing for those 8 parts. That's the first one. No, I think this is the first cash flow. Yeah, this is the first cash flow. So because
Yes.
since
Yes.
we are starting from the maturity, all the other will be initially to 0, and then t equal
Yeah.
to 3. We only have the cash flow that we obtain from here. I just report them here, and that's what gave us the first cash flow matrices. Then
Yeah.
now we go backward, time equal to 2 for the second cash flow matrices. And to do that,
Yeah.
according to what they explained, that we need to first find the expectation by using the regression, linear regression of
Mm-hmm.
degree 2. So,
Mm-hmm.
and first, since I got the cash flow matrices to 1, I fix first of all x to be the stock price at time t2, t, t equal to 2, and y to be the discounted corresponding cash flow at time 3 equal to 3, and that's what I have there. And then from this now, I will be able to look at when, because if since it is a put option, I need to have exactly, I need to choose the part where K is greater than X. The strike is greater than the stock price. So from there, I can eliminate some of those parts where K is not greater than X. And it's give me now, I think I remove 2 and 5. And from there now we can just look at take the since we are looking at the polynomial that will approximate the y value in function of x, which is just the linear regression of degree 2. I use a polyfit, and that, and those are the coefficient of the polynomial that I got there, which give me the conditional expectation function. And then it is with this conditional expectation function that now I will compute the value for x for different parts and compare it with the payoff exercise at that time in order to see if I need to maybe go again backward at time t equal to 1 or not. Yes, so that is it. So the optimal it is optimal to exercise the option at time t for the part where the continuation is just the value of this conditional expectation for x, taking those value from the part that I gave here, and it must obey this expression. So when I do that, the exercise payoff here, those are the parts, the value, and the continuation, which is just the estimation, the value of the option for those different parts. They are there, and I check which one of them satisfy this inequality, and it's only when we observe is only 4, 6, and 7. And from there now, since I have 3 parts now, I can now generate the second cash flow matrices, which is exactly this one. Is part 4, 6, and 7, which I wrote it here. Part 4 is 0.13, 6, 0.33, and 7. But here for t equal to 3 is 0.7 from the previous cash flow. So that is the second cash flow matrices that I got. And then, so the optimal rule to stop the backward is the first instance where we have that the continuation is less than the payoff exercise. So then I need to also to go backward for t equal to 1 and to check those continuation and see if I still have some those continuation, then the optimal time stopping rule, it will be t equal to 1. So the same thing, I do the same thing, and this time the conditional expectation is generated by this formula, this, and when I generate the exercise payoff with the continuation, I got this matrix. Yeah, and I think something is wrong there. Maybe I need to build again. Yes, so when I check, I noticed that it is only 4, 6, 7, 8 that that obey exactly this expression, this inequality. Okay. So then this allow me to generate the cash flow matrices, the third one, and those value are what's given in the time t and part 4, 6, 7, and 8. Yeah.
Yeah.
Okay.
So you have all the continuation value, the maximum between the payoff and the continuation value matrix there.
Yes.
Okay. And
And
when
then
you go, can you?
yeah,
Mhm.
yeah,
Which discount are you? Which discount factor? Where you
the
calculate?
is df. I evaluate it somewhere here. Is exponential of rt. Uh,
Yeah.
I think is up. Yeah, this one. The discount factor on 6% riskless.
Yeah, you have to be careful that for the discount factor because the discount factor changes. Um, because the discount factor basically every time is just uh the delta step.
Yeah.
The difference between two steps. Is it 1 year?
Yes.
Okay, so each step is a year.
Yes, a year exactly. So when
Okay, that's good then.
for the second year now, I will raise to power 2, and for the third year, I will just raise to power 3.
And if it's, I mean, that discount factor, if it's 1 year, is good because you can use that for each time step
Okay,
because
okay.
you always discount 1 year back.
Oh, yes, yes, yes,
So
yes.
that's the only value that you need.
Okay,
You need a delta t between the time step,
yeah,
and because you apply that at each time step, you will just there will be the exponential three year will just come because you're doing the product of 3 times.
yeah,
Hmm. Yeah, carry
yeah.
on.
Yes. So the stopping optimal stopping rule, according to the description of the algorithm, is the first instance in time at which the prime the option is smallest than the payoff uh, exercise. So it should be t equal to 1 the first year, because this is the first time that we observe this inequality. So since I have the optimal time, I can now from the algorithm I just need to do the summation for all the cash flow matrices multiplied
No,
by the
you don't need to do the optimal. You don't need to know the optimal time. You just for
okay,
each time you put the value that is optimal, and
okay,
then for each path you do that until t0. You discount it until t0. So you should
okay,
do another time. You don't stop at the optimal time. I mean, you don't care about the optimal time. It's not the question. The question is just the expected value. So you calculate the expected value for each path, and then you just do the expected value of that. You
okay.
just do the average of that. So there's a last step to go from T1 to T0 that needs to be done too.
Oh,
And
okay,
once you go to T0, then you can
oh,
calculate the expected value of that. So it's not at T1, it's at T0.
or at t0. Okay.
Mm-hmm.
Okay. So me, I stop at t equal to 1.
No,
Uh,
that is 1 year. You're still 1 year in the future. You need to do that to T equals 0.
oh, t equal to 0. Okay.
Yeah.
So it should be the same procedure then from
Yes,
the
exactly.
yeah.
Exactly the same. At T0, you know the value of the payoff.
Mm-hmm.
It cannot be all zero. I see all zero there. It cannot be all zero because I don't know. It's a put that you're doing,
Yes.
and what is what's the value of the put?
Um,
The strike. Sorry.
the strike is 1.1.
Okay. The strike is 1.1, and the stock price is 1.
Yeah.
So the value is 0.1. Then the value is 0.1 at the beginning.
Yeah.
Yeah, and then you compare that to the conditional value and see which one is bigger and put
Okay.
it there.
Okay.
So you do another regression between those zero point 0.1 and and the conditional value and see which one is better.
Okay, okay. Let's see. Okay. So then that means that instead of adding 3 summation, now we add 4 summation, 4 term, the cash flow for t equal to 0 multiplied by the discount factor, uh,
Mm-hmm.
and do the average. Yeah, the average, and for all those 8 parts, and they give me this value, which is
Or
the
maybe the way you do it, you did it. The value at T1 are actually the value at
yes,
0. I'm not sure. Maybe the way how many? I mean, if you have how many time step do you have? You have T0, 1, 2, and 3, right? You have
yeah,
T0, 1, 2, and 3. So you
yes,
should
yes.
have one regression, two regressions. Is you have one regression to get the value because you have the value at the payoff. You don't know you have the value at T3, but you
Mm-hmm.
don't know the value at T. You have the value at T3. You don't know the value at T2. You do a regression, you get them.
Yeah.
Now you've got the value at T2. You don't know the value at T1. You do a
Mm.
regression, you get them.
Okay.
And when you have the value at T1,
Mm-hmm.
it is the value at T0 that you're interested in.
Okay.
So you don't know the when you have the value at T1, that is still 1 year in the future.
Okay.
So you need to find the value today.
Okay.
So again you need to do another regression
Okay.
between the possible value of the stock
Okay.
and the value in 1 year, so you get the value today.
Okay. So that means in total we have 4 catch flow matrices and 3
Three,
regression.
yeah, you need three regression.
Okay. 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 So that's and the yeah the sim. Okay. So now for so the transition to evaluate the CVA uh, for the American Monte Carlo, um, the the formula i- is is given by the loss given at default multiplied by this those factors, and then R here is the recovery rate, which is 1 minus the loss given at default, and the term that we need here the expected
Yes.
exposure, and
Yeah,
the
that's
yes, those are the two that we need to figure out, and yeah, so uh,
I'm only interested in the expected exposure. Everything else is not a problem. For now, it's only the expected exposure that we use American Monte Carlo to calculate. And
yes,
that exposure is basically, you know that when you were doing the pricing, you're just looking at the price at T0. I told you you need to do the average at T0. But now that EE is the price for each time step. You will do the average there. You see the
oh
difference.
uh I thought it's just the cash flow at t equal to 1.
No, that because it's EET is EET. So you
Yeah.
need to do EET0, EET1, no EET1,
Uh-huh.
EET2, and EET3.
Okay.
Because you see that is an integral over time, the
Yes.
CVA. So you need not only the value at 0. EET0 is usually the same thing as the price, the PV.
Okay. Which price? Sorry.
The price of your, if you're looking the price of something,
Okay. Yes.
of a,
Yes. 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 That's true. Yeah.
that would be
Uh,
EET0.
okay. Uh,
So
so
so there you need the price of at all T.
and this one, if you want to use the Monte Carlos approach, we use the same LSQ least square method to do that
Yes.
by also generating some path.
Yes.
And so what I was thinking is the because it is also the E is uh-huh, okay. Yes. Is there any what I was thinking is that if I can have those one directly from the previous calculation that I was having, especially when I was simulating the cash flow from those value.
Yes. You get them from the cash flow. Yes, that's right. You get them from the cash flow. You get them from those matrices that you calculated.
So you mean
But
there's just
the value, there is not the EE is not going to be a matrix. It's just going to be a vector. When you've got all these matrices of optimal values, which is the
mm-hmm,
maximum between the payoff and the continuous value,
mm-hmm.
you do the average across each time.
Oh, okay. The
That's
average,
why it's
yes.
called expected exposure,
Okay.
because you
Oh,
have exposure for each path.
okay.
Where you because you have 8 paths there, right? Then you're
Yes.
gonna use for each time the average there.
Okay. Okay.
And if you could draw that, you can draw a line on your matrix that is the average going through those 3, 4 times step. And then your CVA will be only the integral, the area under that exposure. That will be your
Okay.
CVA,
Okay.
weighted by the PD and the discount factor. But those usually for the CVA that are given to you. You don't you don't simulate them. You might need to simulate them, but for now we're not going to simulate them.
Okay. Okay.
Yeah, we simulate interest rates sometime when we're doing some hybrid products.
Okay.
But most of the time you use just your numerator, your discount factor to do them.
Yes, the discount. Okay. So you see here from those cash flow matrices, the first one that I got at t equal to 2, I have some value here at t equal to 2. We have 0.13, those value, and at t equal to 1, I have those value for the third cash flow.
Yeah, the
And
third one is obvious. The third one, because it's a terminal, you have
yeah,
them from the capital. You need to get the T2, T1, and also T0, because I saw
T0.
you need to find out, because
Okay.
T0, the way you have that, the expected value there is 0, but it's not the
Yeah, yeah,
case.
yeah. Okay, okay, okay,
You should have value there.
okay. And sorry, I need one more clarification. So from this third cash flow, uh, we now since we are at t equal to 1, for the fourth part we have 0.17, and then we set all the other value for
No,
t
no, no,
equal
no, no, no. The 0.17 is not, I mean, it's just one one exposure from one path, which is the path 4. But the actual EE, if you want to get, let's say, the EE for T1, you're going to do
Yes.
the first path value is 0.1, plus second path value 0, plus third path value 0. You
Hmm.
add all of them and you divide by 8.
Okay.
I don't know what is the value. That will be your EE for path for T1.
Okay. I
So those
see.
value you need to do this. It's the average.
Okay.
It's the average that go into the CVA.
Okay.
There are other measure where you don't use the average, where you use some percentile. You hear about some other method where they calculate things like maximum expected exposure, or there are other measures that use percentile of those distribution basically to
Okay. Okay.
calculate some more conservative. But for the CVA, it's just the expected value for that.
They said, okay. Okay. I see. Okay. And for the um uh, probability at default probability for the counterparty. I I I saw a paper. Maybe I will share that. You can you see this my screen? This one
No,
with
no,
several.
I don't see.
Oh,
I
okay.
can't
So
see.
okay, let me share. mm, Amazing group. Yeah, because in that formula is the we are doing the product with the expected exposure with the probability default. So
Yes.
since this was not given, I was looking for a way in order I mean to compute the probability.
No, 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 no. Don't worry about this one.
Okay, so
This has nothing to do. This is
oh,
completely different.
okay, it's completely different. Okay, uh,
The probability is what trying to do arbitrage. This is completely different. It has nothing to do. To get
okay,
probability on default when you do CVA, you use CDSs. You do CDS.
pardon.
You do CDS. You use the CDS spread.
Okay,
So
uh,
if you're trading against I don't know, Barclays, or you're trading against RMB or any company, you go on and see what or how much is the CDS on them, and from those CDS you can extract probabilities.
okay,
You don't use that what you show me. That is completely something else
okay,
that nobody actually use. That I don't know. I mean, this is for arbitrage. People want to use equity market to extract information on the credit market. But that's another topic.
okay,
No, you don't need to worry about the PD, and like I said, those are
okay,
given. They'll give you all of them.
okay,
Usually,
okay,
you could take actually just take 1% per year. Let's say 1% per year.
okay. I see.
You could
One
say
plus.
1% per year. That's
Mm-hmm.
enough.
Okay, all right. Okay, yes. That was the first test. Now the second point where you asked me to read about the FRTB standardized advanced approach. So I read um, the the paper. I mean the document that you sent, and I, okay, I need some clarification. But first, is there any difference between the standardized advanced approach and the standardized approach?
No, no, no. It's the same thing. I mean, in the paper, you will see. It was just for you to get familiar with the when they say FRTB CVA.
Okay.
You can see there that you have two main categories. Some people do what they call FRTB CVA, which is the advanced,
Yeah.
and other people do the basic CVA, which
Oh,
is what I said is a standard basic. You see,
okay.
and the basic CVA you don't need to have a model like a simulation in Monte Carlo and everything.
Okay.
They have risk weight that they give you per risk factor. You don't need sensitivities. They use some kind of risk factor of but when you're doing the advanced one, there are formula there. We
Yeah.
calculate the KB and square root of all this stuff.
Yes. That,
When you read now, it might not ring a bell. It's basically it is based on the CVA calculation that we just did, but even more, it is based on the sensitivity of the CVA calculation. You see that CVA we calculated for, let's say, a put option. Now you need to say, okay, let's calculate the sensitivity of the CVA to credit spread.
mm,
So I told you that let's say that the credit spread was 1%. The
okay.
the default probability was, let's say, 1%, which is based on the credit spread. I don't know, maybe let's say 100 basis point or 100%, 100 basis point, like the cost PD. Now you're gonna bump that the credit spread and recalculate your PD. Maybe it's gonna be now 1.2%. Yeah,
Mm,
and
okay.
you calculate the CVA again, so you have a difference, and you can calculate like a derivative. It is a
Yeah.
sensitivity to that bump, and that will be your CVA sensitivity to credit spread that you plug into the formula of the standard FRTB. You see?
Okay.
So the standard to get the standard FRTB, basically what I want you to understand is that you need to be able to calculate CVA and CVA sensitivities so you can
Ye-
understand.
yes. And actually, there are two type of uh, sensitivity here that they want us in the point 41. Um,
Yeah.
the sensitivity CVA and the sensitivity hedge.
Yeah, don't worry too much about that. Those things are just, let's say, usually in the bank, you will have, like, let's say, if you have an option, like a put option, it is
Okay.
a book in a book, right?
Yeah.
Now there will be a CVA team that manage the risk of the bank.
Okay.
They will go and see if they can go and buy other instruments. They will not buy a put. Maybe they'll buy things like CDSs. Then you mainly buy CDSs to protect the book, and they will put those instruments in a different portfolio called edges.
Okay.
So on one side you have assets like put, call, loans, swaps, stock, anything. And on the other side, there will be a CVA desk that will buy CDSs to protect the default risks of the bank. So that book will be, because you creating an instrument to help your CVA, and but that instrument has a CVA,
Okay.
and his CVA is supposed to, basically the sensitivity of that instrument is supposed to reduce the sensitivity of your book
Okay.
to CVA.
Okay.
You see, so they basically use that to edge, basically to
Okay.
edge
So
the.
and if I want to use okay implement at first of all when we evaluate the weight sensitivity and then we evaluate the or at the bucket level and then later aggregate to for all those buckets that are given. Uh, I I guess when we are going through this computation, what are the input that the bank will give? Uh, s- so for instance, the this coefficient um, M MCVA that's also one difference to, because I was comparing and the FRTB standards approach that the same in different document with with this one, and I noticed that for them they didn't multiply by this coefficient MCVA. So if they multiply,
The MCVA is just a
mm,
multiplier that it is different for each bank.
okay,
Depending on the gap that you have, they can say, okay, your M is gonna be more conservative or not. It's
okay,
just a thing that they give to, to be a bit more conservative. If they see that, for example, you're not doing some of the requirement because there's a long list of requirement there. If you say, okay, we've not done this yet, let's say runway risk. You say we've not modeling runway risk yet, or we're not modeling proxy curve properly. They give you a penalty basically. That factor is a penalty to increase your capital.
oh, okay, okay, okay. So yes. So then
So for one bank it can be one, for another bank can be just two, just double
mm,
the value they're calculating.
okay,
Or sometimes 1.5 or 1.2.
okay. And when we evaluate this K at the bucket level, if you have maybe 2 or 4 buckets, do we just do the normal summation, or we aggregate this quantity?
The
It,
K
it,
is a total I already aggregated. The K is a capital that
oh,
you're gonna have in your balance sheet.
yes, okay, okay, yeah, yes.
CVA capital.
Okay, so then we have two value, this K for the Vega and this K for the Delta, regarding to data sensitivity, and then we add them. That will give us uh, the CVA value that we are looking for.
No, not CVA. This is not CVA. This is a CVA capital.
Yes,
It's
CVA
different.
capital. Yeah, yeah, yes, yeah, yes, yes, CVA capital. Yeah,
CVA goes in your PNL. CVA is like the VAR. It goes in your PNL. The CVA capital go to your balance sheet. It goes, let's say, it's like other capital. It
yeah.
goes into your balance sheet to make sure that you have enough capital to cover it.
Okay,
So you have enough, own capital, which is the value of your share price or your capital market, your market cap. So let's say if your CVA, your market cap has to cover the value of your CVA.
okay.
So basically, if the capital is too high, you have to raise more money from investor to cover your capital.
Okay,
All this stuff they call return on capital. There's a value of return on capital that each bank want to have. They want to have like 12% return on capital. And when the CVA go up, the CVA capital go up, that return on capital will go down. That's why they need to keep CVA down. Otherwise, they will need to sell some of the share of the company to raise money. They will issue more shares, so they will reduce their ownership of the company. Yeah. So basically, that is the two things. I think you've done a good job.
okay,
I think now what needs to it's good to keep this in this FRTB CVA in the back of your head, because most of the consulting work come from there.
okay,
It's good to be familiar, understand. We'll see if at some point, if you get a CVA engine, we can start to calculate some of the sensitivity to see what they look like, and we can have like a mini FRTB CVA calculator, maybe only on two assets, something like that, just like a toy,
okay,
just for you to understand how it works, those formula.
okay,
Um, so now what I wanted to do is to see, depending on your schedule, if you have too many or not much to do,
mm.
it would be good to, what do you think it would be good to push now that you've done this?
Okay, so from the email of last Monday, I still need to read about the collateral CA agreement, and also read about the initial margin SIM. That's the two, uh, 3 and 4.
Yes,
Yes.
yes, I think it's good. It's good to do that,
Okay.
because it's always good sometimes to take a step back and have some kind of, you know, big picture, as opposed to just go into code and spend too much time into coding. Because all
Okay.
these things, they are already available anyway. So it's mainly for you to understand how they work. So it will
Okay.
be good to find some documentation.
Hmm.
If you can share them with me to see if they are
Okay.
good, a good paper to read. I'll
Hmm.
tell you quickly. And yeah, go and read that. And then if on top of that you have some time, what I will recommend is at the end of your Jupyter notebook, write a single function that does everything. You know, you just pass those values, it simulate everything, it calculate all the path. You could choose the number of path you want,
Hmm.
the time step that you want. It's usually not annually. It
Okay.
can be any number of, let's say, period of time. It could be 0.5 years, could be 0.4 years, could be any. It does that, and it give you the let's say the average for each time step, the
Okay.
EE.
Hmm.
Yeah.
Hmm. Okay.
Okay. We could do that, and then if that is good, we could actually I'll show you some code that does similar thing, and we'll be able to compare.
Okay. Okay.
Yeah.
Yeah. Okay. I see. So yeah. Okay. S- uh, that if I sorry if I just is a quick summary of what you are asking. Um is for the evaluation of the CVA from for the American Monte Carlos.
Yes.
Okay. Yeah. Okay. That's okay. Then I will create a
You write
function
one
that
function that does it.
a function that yeah that does it. Okay.
Yeah, that does everything. Yeah. And you can pass input. You know, I want 10 path. I want 100 path.
Okay.
Yeah.
The pattern. Okay. All
And then
right.
I want the time step to be every half year, every quarter,
Okay.
any value.
All right. Good. Yeah. And that's all right. I will do that. And the when do you think we can meet next time for that? Um,
I think let me discuss with Alan, because I think Alan is coming in South Africa next week. No.
okay. I don't know. I'm not so sure.
Okay. Let me. I mean, we could already say maybe sometime. I don't know how long you need. Wednesday or Thursday, something like that.
Okay. Sounds good. We can see Wednesday.
Okay.
Wednesday. Wednesday. And yeah. So I hope that by Wednesday I will be able to do that. And also for the reading for 3 and 4. If I didn't manage to read all, maybe if it's only in the initial margin for and sim, I could also report the level that I
Yeah.
arrive for the reading.
Mm-hmm.
Yeah. Okay. And
Good man.
yes, so I have one last question. I just want to know when we from the FRTB standards approach, the main document, there was a document that I was reading which evaluate the minimal capital risk required for a bank, and that value that we get actually they have three components. They have
Yeah.
the Vega, the Delta, and the curvature, and there is another extra component that they add on. Um, and this capital that we are evaluating, what is it related? I mean, I want to understand the difference between that value and the FRTB standard approach for CVA.
Yeah. That's which one? Which value you mean?
If, yeah, the capital CVA using FRTBSA.
Yeah, that is a capital that you calculate. That is a capital for CVA. You
Yeah,
want to compare that to what?
to the FRTB standard approach capital that we evaluate in general, the minimum capital
I mean,
requirement.
it's the same thing, right?
Oh,
It is
okay.
the same thing. You have something that is called a CVA engine, right?
Mm,
You have a CVA engine that calculates your CVA.
okay.
And now from that engine, you could calculate the capital for the CVA. So all of the thing that you say, the Vega, the Delta,
Mm-hmm.
the they are all sensitivity from your CVA engine. The
Yes, yes.
CVA, so the Vega, for example, is that you see in that put that you calculate, you have a volatility in there.
Yeah.
I don't know how much you use. It was 20%.
Okay.
Yes.
Mm-hmm.
So you use that, you calculate your CVA. Right?
Mm.
You use that, you calculate your CVA. Now, if you bump that value by 1%, now it's like 2.2, 20.2%. Yeah.
Okay. Yeah.
You calculate your CVA again.
Mm.
The value will be different. You bump it and you recalculate your CVA again. The value will be different, no?
Yeah.
And the sensitivity, which is the difference of the two value divided by the value of the bump,
Yeah.
is your Vega sensitivity.
Yeah.
Does it make sense?
Yeah. Yeah.
I mean, if it doesn't make sense, you tell me. It's not obvious. A lot of people will read that the document and don't understand that.
Mm. Okay.
It's really not obvious. So if you don't understand, maybe let me know.
Yeah.
We can rediscuss that next time.
Okay, that's
We
all right.
could go back
Yeah.
to it and go step by step.
All right. That's fine. Yeah.
But
Uh,
there are
okay.
probably lots of things that, I mean,
Mm.
that is probably, it's like you're learning something from the end because
Yeah.
you have not done CVA yet. You're already doing FRTB CVA, which is just something on top of CVA.
Mm. Okay. Okay.
So we can go back to it. Don't worry.
All right.
The most important now is to be able to understand how you do that Monte Carlo and stuff, and we'll go back to the FRTB.
Okay. Okay.
Because usually all this sensitivity you were asking me, you will not, if you go to a bank to calculate the FRTCVA, it is the front office that give you the sensitivity because they use it every day.
Okay.
They will give you Vega, Gamma, all of that.
Okay.
You will not need to calculate it. They'll give you everything. You just plug into your square root formula.
Mm.
You know,
I see.
you will not have to calculate this sensitivity. They're given to you. They come from the CVA engine.
Okay.
And usually some banks, especially in South Africa, they will have even external company that provide them with the software that does all of that for them. You see?
Okay. Yeah.
Yeah.
Yeah. Okay.
But
That's all
it's
right.
good to understand and see each input where it comes from. But we'll get the time to go back to it.
Okay. That's fine.
Kofi is probably working on something like that, no? Of
Uh,
FRTV.
yes, he's implementing the FRTB standard approach engine. So yeah, he's working on that and also back testing. And so
Yeah, but you could also discuss with him to
yeah.
ask him, where does he get the inputs and everything.
Okay. Okay.
But is it a FRTB standard approach for CVA or FRTB standard approach for something else?
Uh, for something else, it's not for CVA.
Yeah, because you have FRTB for everything, right? For
Mm.
market risk, for what they call credit risk DRC. There are many framework. Oh, and the whole point of it is to calculate capital, huh?
Yes,
To
yes.
get you a capital
Yeah.
number. Okay.
Okay.
All right.
Thank you. Okay, see you on
Okay.
Wednesday. At what
Yeah.
time will you be available on Wednesday?
I will be back in London, so we'll be able to do
Okay.
anytime, really, anytime.
Okay. All right. Thank you.
Yeah.
Yeah. Okay. Bye bye.
Okay. Thank you. Bye bye.
Mm.
Bye.